All right, let us start filling in our blanks. So columns, the up and downs, those are our families, and those have similar physical and chemical properties. Our rows, so hydrogen and helium are their own row. These are called periods. They go side to side, and these periods have the same energy levels. And as we get to the Bohr model, that'll become a little bit more apparent what these energy levels, these orbitals are. All right, so let's start with our first column. I would put a number 1 over this first box, maybe label that hydrogen with the capital H. Put a number 1 because this is family number 1. Now this family number 1, you'll notice hydrogen has a different color than the rest of the elements, and that is because hydrogen's a non-metal, but the rest of this family, as well as family 2, are metals. So of course, hydrogen's got to be the exception to the rule. So you're going to put a number 1 here for family, H. Put a number 2 over the element of beryllium. So you should have a number 1 and number 2. You want non-metal, pointing at hydrogen. And then you want metals for the remainder of families 1 and 2. And then you're going to take 3 colors. You can use whatever colors you want. You don't have to follow these colors that are from Microsoft Word. Completely up to you. But you want hydrogen to have its own color. And then you want the rest of this first column, the rest of the first family, the alkali metal family. You want this to be a color. And then you want family number 2, which is our alkali earth metals. You want this column to have its own color as well. So once you have this coloring done, let's go ahead and label the rest here. So you want to put a 2 for row 2, 3 for row 3, 4 row 4, 5, 6, all the way down to 7. You're going to probably need to pause in between because I'm probably going faster than you are. Normally we do this in class. I do it under the dot cam. So pause and do what you need to do as we're going. I'm trying to keep this as simple as possible. I wish I could do this by hand with you. Okay. So once you have these two families colored in, let's go to the back or scroll down. And let's start with alkali metals. So since I colored the alkali metals in with this aqua color, I like to put the color with it. Usually when I do this by hand, I outline or I lightly color all of this in so that this is a key for me. So I know, this aqua color, let's see, where's the alkali metals? Oh, there they are. So go ahead and use the color from your first column. Shade this in here for our alkali metals. And we describe alkali metals with having 1 valence electron. They are soft, they are shiny, and they are very reactive. This is where sodium lives. This is where francium lives. Some people's favorite elements, caesium. So 1 valence electron, soft, shiny, very reactive. And that's why it has a number 1 over it. These numbers on top of the families represent the number of valence electrons. Now our alkali earth metals, that was the second column you colored. So this is this fun yellowish color. Make sure you color that in here. These are alkali earth metals. Our alkali earth metals have 2 valence electrons. Little pattern here. They are also soft. They're fairly reactive, and these are found in the Earth's crust. Moving along. You'll notice we don't have family numbers for our transition metals. We are not going to spend any time with transition metals other than identifying that these are transition metals. We will not be doing any bonding or anything or any equations that require these because these guys follow a little bit different pattern. So we avoid that here in 8th grade. But these are our transition metals. So from this 3rd column all the way down to here, go ahead and give that all one color. And then for your key, where you're identifying, put that same color here. And again, these are our transition metals. And again, the number of the valence electrons are going to vary. That's why we write varied valence electrons. And these are also shiny, they're metallic, and they're good conductors. And no, you do not have to memorize all of this. This should be with you at all times for every quiz that you take and the test we take at the end of 3rd trimester for chemistry. This is your cheat sheet, if you will, but yeah. All right. So first, go ahead and number each family or each column. So this is boron, and this is family 3. This is carbon. This is going to have the number 4. Again, these are going to represent the number of valence electrons. Sorry, that's actually family 13, not 3. Nitrogen is, this whole column has 5 valence electrons, 6 over the oxygen because this family has 6 valence electrons. Fluorine has 7 valence electrons. And then helium, this family is known as noble gases. They have 8 valence electrons. Go ahead and write non-metals. And then you're going to also write metalloids. Now, metalloids, we'll get into what those are. You write metalloids, put a little arrow, and then what I have here in purple, and then you can see there's a thick black line in between. These are our metalloids. So they're not quite nonmetals, and they're not quite metals. And we'll go over that too. But go ahead, get this labeled, and then maybe pause so you can get all that done. Then you're going to come back. I want you to take whatever color you want to use for metalloids, color this B in, and then you go down, you go over 1, down 1. So whatever I have here in purple, make sure you color in the color you chose for metalloids and put this nice thick line in between. Actually, I think you already have that. And then let's color this family, the boron family. Let's color that in, whatever color you choose. And then we scroll down to the boron group. We'll get back to those in a minute. We'll go to the boron group, make sure you color. And all you need to know about the boron group is that it has 3 valence electrons. Our carbon group has 4 valence electrons. Make sure you grab your color for carbon. Our nitrogen group or family has, oh, look at that, 5 valence electrons. Properties vary here in a lot of these. That's why we don't, you could write properties vary, but we don't really need to know that. These tend to be a silvery white color, but again, there's some variations. Then we have oxygen. Guess how many valence electron oxygen family has? Ding, 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 ding. 6 valence electrons. You're so smart. And then where we have our F for fluorine, this is the halogen family. And they have, shocking, 7 valence electrons. Our halogens or halogens, however you want to pronounce it, these are very reactive as well. These are non-metals and these form salts. I wonder what element is there that is very reactive. It's not a metal and it helps form a salt. Could it be chlorine that is a poisonous gas and reacts with sodium with 1 valence electron and they make table salt? Ooh. All right. Noble gases. This is our final family or final column. And our noble gases have 8 valence electrons. We call this, they're in full valence. We're going to find that this is a very stable group. They are colorless, they are odorless, and they are unreactive. Now our metalloids, which you've colored, make sure you, again, I used the purple for my metalloids. They have properties of both metals and non-metals. I think I said that already too. And last but not least, for our coloring, you have these intertransition metals. So you'll notice on your periodic table, not necessarily on this one, but on another periodic table, you will notice that right here, 57 through 71 and 89 through 103, these are kind of pulled out and brought here, these intertransition metals. Otherwise, the table would look, it would be super, super wide and it wouldn't make sense and it wouldn't be very convenient to have to print out 2 sheets and tape them together. So they're just kind of brought down here. So you still want to color those a different color from the transition metals. We have something here called the lanthanide series, and then we have the actinide series. Again, make sure you bring your colors down here where they belong. Our transition metals, again, I had this kind of pinkish color on the lanthanide, actinide metals, your intertransition metals. So for, I think we did transition metals already, for our lanthanide and actinide series. So again, we've got varied valence electrons here, same as in the transition metals. That's why we don't focus on them. Definitely not in 8th grade. Here we have solid metals. Many are man-made. They're radioactive and or they are explosive. No, I do not have any, so don't ask. So that is our periodic table, all nice and labeled and colored in. Also, what I tend to do on my drawing, and I will actually post the PDF of what my handwritten one looks like. I also put the numbers for my rows here just to help so I'm not kind of looking back and forth and using my finger. So next to helium, you can put a 1 and then a 2, 3, 4, 5, 6, and 7. So these numbers up top are going to represent our families not the families, they're representing the columns and they're representing the number of valence electrons. The numbers for the rows are telling us what the energy levels are, how many orbital shells, as you'll get to next, how many orbital shells there will be for each element. Then you should have all this filled in and colored. And then down here at the bottom, so valence electrons are the electrons in the outermost energy level, those outermost shells. I'm going to put that there. I tend to call them orbitals. I think they use the word shells now. So I try to make sure you have all those words so you don't get confused. And then just a little disclaimer about hydrogen again. Even though it is on the left side of the periodic table, hydrogen is a non-metal. So this key is posted with a blank. Super important for you to make your own. You are not turning it in. This is your notes. I can't emphasize enough, if you just print this or you just use this, I don't know that it's going to have the same impact as you actually doing this yourself. And I will also post the PDF of my handwritten one that I've done. Let me know if you have questions. Remember, office hours are Tuesdays and Thursdays, 11 a.m. to 11:30 a.m., and again at 3:30 p.m. to 4 p.m.